All right, class, I've got 15 minutes here, so we're going to talk through the DeltaMath homework. You've got a 5.3 to 5.5 Honors DeltaMath assignment. It consists of a basic flowchart proof, a level 2 flowchart proof, parallel and perpendicular equations, coordinate distance, properties of isosceles triangles, and some reminders of how to do volumes of cone and pyramids. If you get anything else, you will obviously see it as well. But currently, this is what your assignment looks like. We're going to start off by just remembering how to do each one of these. So let's take a look at the basic flowchart proof. Whenever you're looking at the basic flowchart proof, first off, determine what kind of triangle you have for both of them. We see we've got one triangle up at the top here, and another triangle down here, and they've got a handful of matching sides and matching angles. What matters then is how are they matching? Well, let's see. We have a side, angle, side, matching a side, angle, and a side, just like the worksheets have been doing. So we're seeing side, angle, side, and we know they should be congruent if we see side, angle, side. This is from the notes, from your notes worksheet from Monday or yesterday if you weren't here yesterday. So we're going to say they are congruent. And now we have to do just a very basic proof of it. All the reasons are given. Everything in this triangle is already given for us. So what we need to do is identify the things that are given. We need to talk about some side lengths being the same. In this case, JK being congruent to, let's see, J to K, Z to Y. We want to give another statement, either, let's talk about the angle. We have a side, let's talk about the angle. Angle K is congruent to angle Y. And we want to give another side statement. Y to X is congruent to L to K. Or K to L. It won't really affect us which way it goes. We're saying this side with a length of 1 is the same as this side with a marking of 1. After that, we just want to identify the reason. And we identified the reason. We said it was SAS before we even started. So we're going to select SAS from our options, hit submit. You're going to want to do a handful of things like that. Watch out. Check that you're meeting all the necessary conditions for side, 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 angle, side, angle, angle, side, or hypotenuse leg. Check that you're meeting the necessary conditions. We might have a longer proof. This is flowchart proof level 2. In this case, this one's going to be sort of short. We can get through it really quickly. We see B matches D. We see B to E matches E to D. And we can mark those sorts of things down. We can say BE matches ED. The reason is given to us. We see they're congruent. We see some angles are congruent. We see B is congruent to angle D. Again, it's given to us in this case. Last thing we need to consider is what else do we know in both triangles to be true? Well, we can also conclude, let's see, they want angle side angle. We're being told they want angle side angle. We've got an angle, and just to illustrate what we're dealing with, we can draw up our picture really quickly. This works as our picture. We have an angle matching down here. So we have an angle. We have a side matching a side. And we need something else. To emphasize, we have an angle matches this angle here. We have a side matches a side. So we need some angle as well. The only reasonable option to go to is this angle here has to match this angle. We just need to name it. Well, in our picture, that'd be BEA and CED. So we'll say those angles are congruent. BEA is congruent to CED. Now, why are they congruent? Well, we got two vertical lines crossing each other, so we've got some vertical angles, and vertical angles are congruent. You'll see generally more complex proofs than that, but that's another example. You'll see a situation where we want to talk about which equation of a line is parallel or maybe perpendicular to this particular equation. Well, let's start off with what we know. We've got y equals negative 3/5 x minus 7. Focus on what the slope is. The slope is this negative 3/5 currently. M is currently negative 3/5. Since we want to be parallel, to the line, parallel for us is going to mean same slope. So we're going to figure out which of our equations have the same slope. And we'll look to solve each of these. For y, we'll look to solve each of our equations here for y to get y by itself. Looking at this, if I take this first equation, I subtract 3x, I'll have a minus 3x on the right-hand side. Then I'll have to divide by 5, so I'll have negative 3 over 5, which matches the negative 3 over 5 slope. So this looks like it'll be a good answer for us. There are no other answers we would select. All right. Don't forget about how to calculate Pythagorean theorem, finding distances between 2 points. We're going to first off make a right triangle with our 2 points. I'm going to click starting on one of the dots and head straight down. And on the other one, I'm going to click and head straight right or left so that they meet. It's not going to necessarily like to do it, but you can do it. Once you've done that, it's going to say we can answer some questions below. We're going to tell how long the leg is. One of the legs, doesn't matter which one of the legs is too long. The other leg is 4 long. We're now asked to calculate the length of the hypotenuse, the diagonal length here. As a reminder, don't forget about your Pythagorean theorem. A squared plus b squared equals c squared. I can plug in 2 for one of the sides. I can plug in 4 for the other side. I'll get 4 plus 16 is c squared, or c squared equals 20. We will have c equals the square root of 20. Now, you might need to simplify this. We are being asked to put this in simplest radical form. Let's remind ourselves how to do this. 20 has to divide by a perfect square. If 20 is going to divide by a perfect square, it's going to divide by a 4 and another 5. 4 times 5 makes 20, and 4 is a perfect square. We can square root the 4. The square root of 4 is 2. We don't need the radical anymore. We'll have 2 square root of 5. So down here for the answer, I'm going to write 2, hit the square root button, hit 5. Submit our answer. For isosceles triangles, it helps to draw a picture. In triangle HIJ, we'll make this H, I, and J. They're saying H to I is the same as J to H. H to I is the same as J to H. and they're saying angle H up at the top here is 118 degrees. Well, luckily we know these bottom two angles have to be congruent because these two sides were congruent. We're going to find angle J by subtracting 118 from 180. 180 minus 118, 62, and divide it by 2 to get 31 degrees. 31. Then you've got practice with volume of a cone. You're going to be asked to find the volume of the cone. In this case, we're rounding to the nearest tenth of a cubic centimeter. I would just sketch for yourself a really quick picture of a cone. Let's see, it has a height of 12.7, and it has a diameter across the bottom of 18.9. If our diameter is 18.9, let's consider our radius. Our radius is going to be half that, 9.45. Remember, your volume for a cone is 1/3 the area of the base times the height. You can find that on your reference sheet. And you're going to need to find the area of the base, the area of the circle. We'll do that. It's 1/3 times pi times our radius squared times 9.45. Make that a nicer 9 squared times our height, 12.7. We can enter that all into our calculator. We could also use the DeltaMath calculator over here. I'm going to click calculator, and I've got a calculator up. I can type in 1/3. I can type in pi. It's going to automatically multiply it. Parentheses, 9.45. I'm holding shift and hitting 6 to get a power. I'm typing in the power. But if you're not sure about that, you can always hit the square button here, or you could hit the a to the power b button and type in 2. And I'm going to hit times 12.7. We're finding our volume should be 1,187.67 cubic centimeters. Round to the nearest tenth. We'll show 1,187.7. Submit. If you're doing it for this one, you're being asked to leave your answer in terms of pi. As a reminder, leaving your answer in terms of pi just means doing all of this math, but without using the pi button. So we do 9.45 squared. Doing all this math, but just getting rid of pi. So I just get rid of pi here really briefly. Get this decimal. It's not great, but it'd be that decimal times pi. For this problem, it'd be slightly different though. Let's see, I've got a radius of 6. I've got a height of 12. I got 144. I'd go 144 pi. That would be my answer. You've got the exact same idea followed up with pyramids. And yeah, you got 2 questions of the same kind with pyramids. All right. That's your notes of what you're going to be sort of working on tomorrow. Work to help each other when you're working through the proofs here. Flowchart proof level 2 is going to be difficult. It's not always going to be easy. Think back to older notes. Think about parallel lines. Think about alternate interior angles.